Good morning, everyone. This is going to be the lead-in to a discussion of how to use matrices to do transformations of shapes, and something you're going to be doing and probably have been doing in 3D drafting and drafting 1, ever since going back to paper G.I. Joes. This moving things, shapes around in 3D space is something we do from the very start of playing around. But what I'm going to introduce you to here is the general overall concept, looking at an engine that is truly kind of designed from the 3D, again, started in 1999 by a bunch of architects. And so I'm going to give you this demonstration just to show you a couple of the similarities of input to AutoCAD and to the methodology. And so you come in typically to SketchUp with a 3D view, because that's by default what it really thinks you're going to do. But you can change that to a top view, camera in a parallel perspective, and you got this general bit here. What I'm going to do is going to draft 300 feet north and 300 feet east. Instead of using the most basic tools, I'm going to use the relative coordinates, which is you're going to see down on the left here. So in this program, left, I click a button, it wants to find some snap point, you get it in the right direction, and instead of using the @ like you would in AutoCAD, you use for relative coordinates you go down to here. You click in there if you need to, and your keyboard has to be on. So I'm taking my time here. Turn on the keyboard. Yeah, I know. I'm gonna get a little sheet of paper here that tells me to turn on the keyboard in the morning. All right, so I'm gonna go ahead and hit escape again. That doesn't work. Escape because the keyboard's not working. We're gonna escape out of here. Click around, hit escape, and do edit, undo, draw line. Edit, undo, draw line, edit, undo, draw line, and I'm not sure why those lines are there, but it looks like it's finding the keyboard now. Alright, so I can either click here, or in this program I can type L. I click there, I get in the general direction, I use a less than greater than, so I'm going to go 300 feet. I'm not sure in my units right now. Feet, comma, 0 feet, comma, 0 feet. Once again, be aware that you need that third coordinate in many programs. And if you notice there, I took that 300 in the X. That's fine. Myself, I have to then click that, hit an escape now, click here, click on that, right click, erase. I can now turn off my axes so you can see that better. And now I'm going to go, once again, this time I'm going to go 300 up. I click on it. I could just type in 300 here, but I want to get used to relative coordinates. So I'm going to go 0 feet, comma, 300 feet, comma, 0 feet. Now, if there is one, once again, I finish out, hit an escape, click, select, and out, because I really don't know how to finish out a command that well here. Now, what you'll see, and we'll try it here, is the fact that the one thing SketchUp does not have is a fillet command that works so well. So you can do all kinds of different things, but one thing one could do, if you start knowing your circle geometry, I could do a circle here, right from there to there. Now I've got something there. Now, in effect, I could now draft a circle from there, like that. Not the best geometry, but we'll see if that works. I'm going to go ahead and erase this out. So learning how to do fillets, and that basically you'll see comes from, fillets are going to come from the fact when you know how to do a kind of erasing here, when you know how to grab things off the web. There's going to be a Ruby that'll do a fillet for us. So we're going to see whether that in fact took, and at this point we're going to generally be our expectation that this is not a perfect fillet, because you see how SketchUp makes things in little straight lines. But we have our alignment there. That's all well and good, and it started at 0, 0, so we're going to move this out now. I grab my things, I grab my tool, I go from here to here, and I go back out. Alright, so that is the alignment to which we want to bring our typical cross section here. And you're going to see, once again, I'm going to turn on View, Axes. I'm going to draft, because you really want to at least think that your typical section is right there at the 0, 0. So I'm going to draft right now, just arbitrarily, a typical section starting there. So I'm going to go down here, You see it's trying to grab a little bit. I'm going to go down. And I could, once again, use my relative coordinates if I wanted to. But I'm not. This time I'm just going to draft through here. Make this one a little bit steeper. And back up. Okay, so now I have essentially some relative coordinates. In this thing, you actually do something called grouping as opposed to blocking. So I'm going to take all this. I'm going to right-click, make it a group. So I know I have that. Now, what is the mathematics of getting this turned to any direction here? It is a question of rotating about the x-axis and then rotating about the z-axis. So what I'm going to do is I'm going to right now just kind of draft, if I would, from here. I can't really grab the center, can I? That looks like it's the center, so I'm going to draft some arbitrary direction there. And of course you know that that direction is 90 degrees from the tangent direction. So what I want to do is I want to rotate this shape first about the x-axis, then about that axis, which we're going to bring over here, and then we're going to move it. Alright, so how do we do that? Well, the one kicker in this program, again I'm going to point out, I'm showing you this. This is pretty easy. It's going to be easier to do by matrix transformations. I'm going to make a little, more or less, a world where I'm hitting P for push here, where I've got my three axes. Because what I want to do is I want to rotate about the x-axis. I do it this way. I select my thing. I grab my rotation tool. I think it's R is the key, and I grab the face and hold the shift key. I go to my rotation point, click here, and I go down 90 degrees. That thing is now, if I go back to camera, standard views top, there it is. It's right where it needs to be. Now, you're going to see in this program, as soon as things cut across each other, they get cut. But what I'm going to do, just to keep with the same mathematics, is I'm going to now rotate it and then translate it. So what I'm going to do is hit here and I hit the control key. So I do a copy. You do a lot of that in this program. I'm going to go to here, get this all the way back to 0, 0. Now you see I have rotated once already about the x-axis. Now I want to rotate about the z-axis. Camera, standard views, top. How do I rotate about the z-axis? Very simply, I select my thing. I grab my rotation. I go from here to here. I turn it. Now it's rotated about the z-axis. So that first rotation that we did was called pitch. This is called yaw. And we will not be doing rolls about the y-axis, but this would be where we do it. Our last step now, if we would, is to grab our thing, grab the move, grab from where I'm going to move it, and I can't. I'm going to move it there. I'm going to take it all the way to there. And as I do this now in 3D, I'm going to get rid of that line, which I don't need, erase. Get rid of that line, erase. And you will see that shape is now inside of that. Now, just for grins, we're going to see whether we can actually, we can't really do anything with it, but in the end, I'm going to go ahead and explode that now, and I'm going to go ahead and connect it up, and immediately that finds the face, and we're just going to see whether this thing, I grab that tool there, and then I hit follow me and click that, you see that it kind of will design at least part of that road section. Alright, and that's typically your extrude or whatever else. Right, so what you'll see in that is, I'm showing you this, it's really not bad in Sketchup and it's actually fun, but I'm pointing out in a preface to the rest of what we'll be doing in Civil 3D and Sketchup and Inventor is the mathematics of transformations, rotations about axes, and translations is going to be something that if you master it, you're going to be much more efficient, not just in dealing with these 90-degree rotations, these 45-degree rotations, but all rotations upon which all of spatial math, civil engineering, survey, mechanical engineering is based. All right, we'll post that out. We'll talk about the steps, and this will be then followed by 3 videos talking about transformation matrices, which you are expected to watch and very soon to master. Thanks for listening.